Have a nice day, everyone. This time I will return to the jet engine propulsion theory, part 2. Quick revision about the equations, then the energy, potential and kinetic, then go to the Bernoulli Principles. After that we go to static and total pressure, ram pressure, then go to the pressure versus velocity through the engine. The last thing is the Brayton cycles. This is the subject which we go to there. Now, this is the velocity equal distance over time. The acceleration is the difference between velocity initial and the end or beginning, and this is the time over the time. Force equal pressure multiply area. Work equal force by distance multiply distance. Power, force by distance over time or work over time. Potential energy is mass by gravity by height. This is altitude and this is the gravity acceleration. Here kinetic energy means half mass multiply velocity square. Okay? This is the potential and kinetic energy. Bernoulli Principles, the conclusion of it is the kinetic energy V square over 2 plus G. G means gravity acceleration, Z which means the height or altitude. Here is the pressure over rho. Rho is the density of air. At any point, these values, if this increase, so this is decrease. If this decrease, this is increase. Means at any point, the summation of them we equal constant. V is the velocity or the speed of any fluid or air. G is the acceleration due to gravity. Z, the elevation or the height of the point above the reference plane. P is the pressure at any point, chosen point. Rho is the density. Okay? Here, how to measure static pressure and total pressure. Here, static pressure, look here, at the here at the surface here of the cylinder here. So it is in the but the total pressure is here from here, and this is static, and here is dynamic, and the look here. This is the difference here. This is the static pressure from here to here. Here the dynamic from here to here. This is the total. This is the total pressure. If you subtract the static from the total, you will get the ram. Where in the airplane we can make that? This is props here, static, at the surface of the aircraft in front here. Look here. This is the landing gear here, the nose. This is the engine. Here, go to the nose. Here, this is the static. The static here. It is. What about the total? The total here, props here, which is the total pressure here. And this is the ram pressure. Take the total pressure minus the static pressure. So this is for the total pressure and here for the static pressure. Here the distribution, the pressure and velocity through the engine. Here the compressed. This is the compression here. The compression here, the pressure increase. The pressure increase and still constant. Then at the turbine, the pressure decrease. Look here. This color here. This is the pressure according to the compressor stage. Increase, increase, increase. Approximately constant here. Then decrease here. Okay. The velocity here, and here the velocity. So this is the velocity according to the pressure during the stations of the engine. Here the total pressure increase during the compressor section and still approximately constant during combustion section, then decrease during turbine section. The Brayton cycle is known as a constant pressure cycle because the pressure is fairly constant across the combustion section, as we saw, of the gas turbine engine as the volume increase and gas velocities increase. Look here. This is here compressor, and here the combustion, and here the turbine. Look here. I will make zoom here. The point 1 to point 2 here, the pressure increase. The pressure increase. But S means, I will show you after that. This is entropy. Entropy. Here Qn from point 2 to point 3, heat added during combustion. Then from point 3 to point 4, the pressure decrease. The S, the entropy, is constant from 1 to 2 and also from 3 to 4. 4 to 1, the heat out. The heat out. This is the pressure according to the volume. Take care here, volume, not velocity. Here, Ts, T temperature, S entropy. From point 1 to point 2, the temperature here increase. From point 2 to point 3, Qm means add heat during combustion. The pressure is constant. The point 3 until 4, this is the temperature decreases. And from 4 to 1, the heat is out. This is the Ts. Look here. The P, where P pressure, V volume, not velocity, T temperature, S entropy, and Q is the heat added or rejected. I give you easy example for entropy. What means entropy? Here, the entropy, the measure of system thermal energy per unit temperature that is unavailable for doing useful work. Example for that, when you refer to ice during melting to water, the ice at 0 degrees centigrade until the water also reach the 0 centigrade, 0 degrees centigrade. This is from ice to water. It is example for entropy. Okay. After that, the next video, I will speak about the Newton's law, the 3 Newton's law, the first and two, and second and third. I think that is enough today. Thank you very much, and goodbye.